Let's look at the first few homonuclear diatomic molecules. For H2, we have 2 electrons, one coming from each of the hydrogen atoms, and all of the electrons in the molecule are going to end up in the sigma 1s orbital. Then we can look at the helium-2 molecule, He2. Each helium atom has 2 electrons. And if we fill our molecular orbitals with those electrons, we get this. Then we can look at lithium-2, Li2. Each lithium atom has 3 electrons, which means the Li2 molecule has 6, and again we fill from lowest to highest. Out of these 3 possible molecules, H2 and Li2 are real. These are real single-bonded molecules, and He2 is not. And we can explain that just by looking at the relative number of bonding versus anti-bonding electrons. In the case of H2 and Li2, you have more electrons in bonding orbitals than you do in anti-bonding orbitals. And that means that there's a net attraction of the nuclei. They're being pulled together. If you look at the He2 molecule, you have 2 bonding electrons and 2 anti-bonding electrons. So the result is a net zero attraction. And there's actually a mathematical relationship or equation that relates this relative number of bonding and anti-bonding electrons. And that relationship is known as the bond order. So the bond order is 1/2 of the bonding electrons minus the anti-bonding electrons. So for hydrogen, you only have 2 electrons, period, and they're both in the sigma 1s orbital. They're both bonding electrons, and there are no electrons in the anti-bonding orbital, so the number is just 0. So 1/2 of 2 minus 0 is 1, so hydrogen has a bond order of 1. And in general, a bond order of 1 implies a single bond, 2 implies a double bond, and so on. With lithium-2, you have 4 bonding electrons. You have 2 from the sigma 1s, and you have 2 from the sigma 2s, for a total of 4. You only have 2 electrons in an anti-bonding orbital, the ones that are in the sigma star 1s. So you look at the total number of bonding electrons, subtract the number of anti-bonding electrons, and divide that number by 2. You can also just focus on the valence electrons instead of looking at every electron involved. So for lithium, the valence shell is the n equals 2 shell, so we could have focused on the n equals 2 electrons. So everything in the red box would be a valence electron. It has the highest n value. So we could have just as easily have written 1/2 of 2 bonding electrons in the valence shell, the electrons in the sigma 2s orbital, minus the number of anti-bonding electrons, so 0 electrons in the sigma star 2s. And that still equals 1, implying that lithium-2 still has a single bond. For the helium molecule, He2, the bond order is going to be 0. And if you get a bond order of 0, that implies a net zero attraction, and there is no bond.